Alright, so we are now working on the Module 5 pretest. I'm just going to be doing the first problem in each section so that you can get a feel for how you should be doing the rest of them. So for the very first one, this is just working with exponential rules. So this first one says write in expanded form 8 to the 9th. So it's just basically, do you really understand what 8 to the 9th means? So since 8 is our base, 8 is what's being repeated, and 9 is how many times it's being repeated. So I need 8 times itself 9 times. 8, 9, and just like that. So that'll be the same for this one where we're expanding it out. And then this one, you actually are going backwards. You need to condense it down into that exponential notation, so which means you'll have the base, which is -5, and then how many times it repeats, which is 4. Next section. So these are applying our rules. So basically just do you remember what to do with like product rule, like zero rule, all those sorts of things. So I would recommend working with your notes, and I'll try to put some links up in case you don't have your notes with you. So working with this very first one, there's not much we need to do except that we need to get rid of this -2. You need to leave all of your answers with positive exponents. So there's not much that needs to be combined in this one, but I need to do something because I can't leave it as -2. Now there's a couple ways we can think about this one. I can either think about the fact that I can move this underneath 1 and then it becomes positive, but then that's kind of gross because then it's a fraction and a fraction. Or I can think of putting this -1 on both this -2 on both the 1 and the 6. Which means both of them need to move place. The 6 needs to go to the top, the 1 needs to go to the bottom. Don't lose track of the fact that it's that negative. So the 6 goes to the top, 1 goes to the bottom. And you could leave it like that. That's a perfectly fine answer. If you wanted to dwindle it down a little bit more, we know that 1 squared is just 1. So really, overall, this would be a -6 squared. But again, I would have accepted this one as well. Okay, so go ahead and go through and you're trying to get them as simple as possible. So combining each base together and making sure you're leaving your exponents as positive. Down at the bottom of the front page, we're using our numbers in scientific notation. So this is putting them in scientific notation and taking them out of scientific notation. So let's start with this first one. I have 456 million. So your very first number is always a number between 1 and 9. So even though there's this 456, I'm actually going to write it as 4.56. You only want one number out past the decimal. And then this times 10 is going to represent how much I shrunk this number to make it 4.56. So basically the decimal got moved from here all the way to here. So I'm going to put an exponent here to represent the fact that I moved it 3, 6, 7, 8 places. So this is telling me this is 8 places bigger than it appears, just like that. So that's the same thing you'll do with this one, except by going smaller, so it's a negative as your exponent. And then with these two, you're actually expanding them back out. So it's not actually 8.4, it's actually 8 places bigger. Okay? Okay, moving on to the back or the second page, depending on how you printed. Now we're just using the scientific notation for comparison. It's basically just saying, like, do you understand scientific notation enough to tell which number's bigger? Now, the first thing you need to do with these is to look at the powers. The first numbers themselves don't matter too much. It's really about the powers. Just in the same way that 1,000 is bigger than 700, even though 1 is not bigger than 7, it's about the place, right? So actually just looking at 10 to a -2, 10 to a -3, the -3 is actually smaller, right? Because that means this decimal needs to be that way 3 places. So the -2 is bigger. So go ahead and finish that up with the other two. Next section, perform operations. So one of your standards, of course, is that you know how to add, subtract, divide, and multiply with these scientific notations. Now, addition and subtraction is the hardest because you have to make sure you have the same place for them. So like with this one, you can't just add them straight like this. You're going to either turn the 1.2 times 10 to the 4, you can expand that out and then add that to the 11,000, or you can condense down the 11,000 into like 1.1 times 10 to the whatever. As long as the power of 10s are the same, then you can add them. So addition and subtraction, you need to make sure they have either the same power of 10s, or you just expand them out before you do those. With multiplication and division, you're basically just doing exponent rules. So I'm just going to start with the multiplication. So really what we can do is we can just multiply the first number, so 1.4 times 4.6, and then I'm doing product rule with 10 to the 4th and 10 to the 2nd. In product rules, I am adding them. So I just need to know what 1.4, let's see, 1.4 times 4.6, and that is 6.44, and this would be a 6. And then don't just settle when you have something like that. Double check that it is proper scientific notation. Sometimes during the multiplication, division, whatever, you end up with something that's the front number's not scientific notation. You need to balance it out. But this one, 6.44, that is. So this is our full answer. All right. For this next section, we're just making sure that you understand what these things are saying. So all these are scientific notation, you just need to tell me what it is. So these show the scientific notation in the different forms that your calculators will use. They're all just the front number is the number on the screen, and then sometimes they'll have a little 10, sometimes they'll have an e, and then that little number is the exponent on the 10. So like this first one is 7.88 times 10 to a second, and that's all you need to do on there. Down at the bottom, this is using our formula for the volume of cone. I encourage you to actually use Google on this just to make it go faster. Make sure you do less errors, all those sorts of things. So here on this very first one, I have a radius of 3. I have, it kind of looks like a slant height of 5. So I have an actual height I don't know right now. So I'm going to need to use Google for this. So if I put in Pythagorean calculator, then if I do Pythagorean calculator into Google, it will actually come up with a screen where it will calculate it for you. So I have A as 3, B is the unknown, and 5 is the height, or 5 is C. So you just switch it over to finding B. You put in that A is 3, C is 5. Now you want to do this longhand, it would be 5 squared minus 3 squared. You'd get 16 and then square root that, but the height here is just 4. So now that we have the actual height, go back to Google, type in volume of a cone, and now we're going to put in those parts that we found. So radius is 3, height is 4, and they're telling us that the volume is about 37.7, and we're centimeters cubed, just like that. All right, moving on to our last page. So now we're on to cylinders. This very first one's very basic. I have a radius of 2 and a height of 6.5. So just be careful depending on what they give you. If they give you diameter, you have to divide that in 2 to get radius. With one like this where it's slanted over, this is still the height, you know, stuff like that. So I'm going back into Google. Instead of cone, I'm going to put volume of cylinder, and then radius of 3, height of 6.5, and I'm getting the volume is 18378, and it's inches cubed. And lastly, we have sphere. So again, like this one, like there's not much that happens with it. You just need to be careful if they're giving you the diameter, so you have to divide that in 2 to get the radius. If they give you the circumference, you just need to use that to find the diameter. So you take the circumference, divide it by pi, that's the diameter, so divide that in 2, and that's the radius. So sometimes you have to do a little extra work, but it's not too bad. So let's just do this first one. So again, use Google, so typing in volume of sphere, and then putting in that my radius is 5.2, and I'm getting 588.98, and it's feet cubed. So if you're using Google, like these volume problems will go by really, really fast.